Okay, welcome to the second video in the Tectonics cluster topic 2. Right, in this particular video, we'll be looking at the first part of how tectonic processes affect the magnitude of volcanic eruptions. We'll be looking at how volcanoes are formed, as well as a little bit on the impact of the tectonic processes. Okay, so this is an eruption recorded of Mount Merapi in Indonesia. Right, once again, it's a stimulus video. Hope you can watch it soon after the content video. So basically what a volcano is a landform that happens when lava hardens after it erupts from the Earth's surface. So what is lava? Lava actually is magma. Magma has two names. When it's under the Earth's surface in the mantle area, en route up, it is known as magma. The moment it erupts onto the surface itself, it's called lava. Structurally, chemically, it's the same thing. It's just taken on a different form, so we call it a different term. Okay. Generally, when you think of a volcano, in our mind, we think of a cone-shaped mountain, much similar to, I think if I ask anybody to draw Mount Fuji, you'll be able to draw something that is like a little inverted ice cream cone of sorts. Okay. However, do note that there is only one type of volcano. There are many, many different shapes that different volcanoes can take. The different shapes they take is a result of the type of lava that is prevalent in that area. Key terms for describing a volcano, right? The first one, the crater, right? Crater is actually the top, the bowl-shaped depression at the top of a volcano. You may be wondering, isn't the volcano shaped like a pyramid? Actually, it isn't. There is always a crater. If the crater actually encounters a very large explosion and the whole crater top is blown away, you have a massive, massive opening. That is another term for it. It's called a caldera. Okay, but in your syllabus currently, these are the basic terms you need to have. Okay, vent. What is the vent? Vent is the opening where the lava flows out at the top. Okay, at the crater area, at the bottom of the crater where it connects into the conduit or the pipe. Okay, this area here is called the vent. Conduit, which we mentioned earlier, or also known as the pipe in some of the other guidebooks or whatever notes or even on online resources. Another term for this is the pipe, right? It's the central passageway. But when you're looking about conduit, you're looking at the main passageway that connects the magma chamber, which is below the volcano, okay, the source of all your problems, with the crater itself, with the vent and outwards to the crater. So the main one is called the conduit. If you use the term pipe, right, sometimes you'll come across terms called the main pipe. Okay, that is the conduit. Okay, there are many pipes because sometimes you do have sideways pipes that come out from the side. So if you're talking about the conduit, you're looking at the main pipe that connects the magma chamber to the vent itself. Right, so at a divergent plate boundary, if you have an oceanic divergent plate boundary, in topic 1 videos, we talked about and we drew diagrams to show how this can actually form submarine volcanoes or volcanic islands. So this actually is what happens when you have fracturing, right? Sometimes the magma is able to then come out onto the crustal area and it cools down, okay? And when this happens, it actually pulls up and it cools and it forms a little sort of dome. So with subsequent carrying, more magma is pulled out and you eventually encounter something that builds up as a submarine volcano or undersea volcano. If you give it enough time, this will again build up even more and it will emerge at times, if the conditions are right, as a volcanic island. So bear in mind, there are many, many caveats to forming a volcanic island. So it's really magical and it really needs many conditions to be aligned before this can happen. This is also why we don't really have many, many volcanic islands, but we do have a good spread of undersea volcanoes, submarine volcanoes along divergent oceanic plate boundaries. Right, so these 5 points here form the description of what happens and how undersea volcanoes can form at divergent plate boundaries. So if you were to be tasked with a question like this, how do tectonic processes at divergent plate boundaries result in volcanic eruptions? 3 to 4 marks. Drawing the diagram is useful. Having this as accompaniment is a must. Okay, but reminder, your answers in your papers and assignments have to be written as a paragraph. You cannot give us in point form, you cannot give us in numbers, they will not mark it. I repeat, your answers have to be in a paragraph, it cannot be in point form, and it cannot come with numberings. Okay? So no bullet points, no numberings. These 5 points here, string them together in a paragraph, and you will have your answer. What about convergent plate boundaries? Now, this is the other type of plate boundary that will form volcanoes together with your 4 mountains. Okay, this is where one continental crust pushes against an oceanic crust. Now, the oceanic crust is denser, so it will subduct and it will melt. Okay, but the oceanic crust is not purely oceanic crust. You have to understand that the oceanic crust, right, at the point where it is coming in contact with the surface, has impurities in it. So as you move in, these impurities like water, right, will go into the cyanosphere, the upper mantle area, and then it will melt and it will form gases which need to escape. So the gases will very naturally try to escape up through lines of least resistance. Okay, that's what we all do, right? We pick the easiest way out. So they will try to escape through lines of least resistance where there are fractures in the upper mantle as well as in the continental crust itself. And as these break through, they widen these gaps. So what else can come through? Other things like your mantle material can pull through as a result and form things like magma chambers and eventually fracture out and erupt as volcanoes. So this is important, right? This is how your volcanoes happen at convergent plate boundaries. Once again, 5 points, right? You must know this. I repeat, you must know this, because if they do come up with a question like this, you are expected to be able to explain using terms like this. No bullets, no numberings. I repeat, no bullets and no numberings. You will get a 0. They can also give you a stimulus diagram like one of these and tell you to describe how volcanoes can occur at such plate boundaries. Okay, Erta Ale volcano. This is a shield volcano, a non-explosive shield volcano. Right, video. Please go and watch this. Pinatubo, the second video here, is a highly explosive volcanic eruption because this is a stratovolcano. Stratovolcano will come back and haunt you later on in the next video. Right, so June 15, 1991, you were not born. Your parents would have been born, I'm pretty sure, but this was something that happened within my lifetime. Okay, in the Philippines, we didn't feel the tremors, even though it was a very big one. But in Singapore, we did, and I wouldn't say enjoy. We did get a couple of weeks of ashfall as a result of the massive Pinatubo eruption. Okay, when you have an eruption like this, the key things that come out is not only lava that comes out. You have a lot of ash, you have a lot of gas, and it can be injected into the atmosphere itself. And if it's injected high enough in the atmosphere, it gets caught up by the trade winds and the local and regional wind currents. It will be spread across. Okay.
In the Philippines, after 611 years of slumber.
Right. So what actually determines the magnitude of this eruption? We are going to be looking at the type of lava at the area itself, the magma that is based in the area. How do we classify this? We classify them in terms of the silica content. Okay, so if you have a lot of silica in the magma versus you have very little silica in magma, it will have a very clear impact on the eruption. Okay, so what exactly is silica and how does this work to impact eruption magnitude or the type of eruption you have? Okay, silica, think of it as something like something you add into your drink. Okay, adding sugar into your plain water. Okay, if you have some sugar in the plain water, your plain water is still going to flow like water, right? It's going to be easy to flow around. Okay, but if you continue to add water, sugar in, and you stir and you stir and you stir, eventually you end up with something that is so thick and viscous it looks like honey. Okay, so what happens to that then? When you have things like that is called high viscosity. So high silica content means your magma is going to be high viscosity. When it erupts out, it will not flow fast away. So what will happen at the vent? The vent will get clogged up. When you have clogging up of the vent, the gases will build up underneath it, and it takes a while before the gases build up enough pressure for the eruption to occur. So because you are able to block up the vent very, very well and very, very tightly, when you have high silica content, your eruption tends to be big and explosive. If you don't, okay, if you have very low silica content, very fluid lava, when it comes out at the vent, it is able to flow away very quickly. It doesn't form a thick plug at the vent. Okay, it doesn't form a thick lump at the vent. There is ability for the gases to break through because it's not very thick. There's ability of it to just gather a little bit and then able to break through already because it's not very thick, it's not very sturdy. Then your eruptions at these locations, because the dissolved gas is able to be released constantly with less pressure buildup, your eruption tend to be less violent, less explosive. Okay, and when you erupt, you tend to not have clouds of ash being ejected into the sky because it's a smaller explosion. Okay, so high viscosity magma will lead to the formation of stratovolcanoes. Low viscosity magma will lead to the formation of shield volcanoes. Right, this is a very nice table to end with. This shows you the viscosity that you find as a result of the type of silica that is found in the magma and the associated volcano type that you have. Okay, very useful diagram. Hopefully you can commit this to your memory and use it to answer the questions as needed. So I will stop here because the next video, the next section, right, I will move on to show the differences between a stratovolcano and a shield volcano. It's not just the shape, it is also the type of eruption and the ability for you to identify based on a picture and give us the supporting evidence is key. So in the next sub video, you will see the portion on difference between a stratovolcano and a shield volcano. I'll see you in the next video.